Hey everyone, Sean McBride, aka Bushido Codes here. This is the first video of a new series that I'm recording with my friend Joe. Joe and I have something in common. About a decade ago, in 2016, we attended Full Stack Academy, a coding bootcamp to be able to learn full stack web development. Prior to attending Full Stack Academy, I had been working in low-level mainframe system software, and Joe was, I believe, working as an English tutor in Korea. So he speaks basically fluent Korean, which is pretty cool. And he and I have gone different directions since then. I sort of reverted back to systems programming space, but initially within the context of WebAssembly. So kind of bringing together some of my pre-existing systems knowledge and the web knowledge I picked up at Full Stack Academy to synthesize those together. Joe ended up going into higher level application software. He did web, and then he got into Go and Python and a lot of backend kind of stuff. And very recently, Joe has successfully liberated himself from working at Amazon and accepted a new role at Meta, which is very exciting. And the new role is going to be a systems role. So he and I were grabbing a beer together recently, and we thought, hey, since he's picking up a lot of this systems programming stuff, C and C++, fresh for the first time as a mid-career professional that has gone through a coding bootcamp and not done a traditional computer science education, wouldn't it be cool if we go ahead and try to record a series to allow other folks to go on this learning journey together with us? I don't think this is going to be unidirectional. I think, like Joe in particular, is extremely strong at leet code grinding, and he has really cracked the coding interview, which is something that I'm going to have to handle in the future as I prepare to go back into the job market in a couple of months. So probably we'll do a mix of some basic C and C++ stuff, and then we might have some episodes where we kind of reverse, and he teaches me about how to basically more effectively memorize different data structure and algorithm things and be able to prepare to be able to do kind of a higher pressure coding test, that sort of stuff. So that's kind of what we're thinking. For this first episode, we did end up having some audio issues. I'm gonna go ahead and try to edit out the issues in post. Essentially, it turns out that the thermals on Joe's System 76 laptop kind of suck, and so the sound of the fans were basically getting picked up by his microphone. We'll get that figured out, and we just ask your patience. So with that, I hope you enjoy the video today. If you have any particular feedback or questions about anything you see, I will be monitoring the comments, and I'd very much love to help you be able to achieve your learning objectives as well. So hope this is helpful. Enjoy. All right. So hello, everyone. We are currently here with Joe, a ex-Amazon employee. Joe, what are you up to these days?
I'm learning C and C++ and operating systems.
Exciting. Okay. So that brings us to what we have up on the screen here, Compiler Explorer. So I want to have a little bit of a discussion what you want to cover, but Compiler Explorer is kind of like the dominant tool for just being able to have like a REPL. So let me just say a little bit about this. So a bunch of languages are supported. So like, I know you are a Java enthusiast. You love that language, right? Big time?
I've been coding in Java since I started at Amazon.
And all right, so if you wanted, you could do some of that sweet Java code in here. We also have C. We've got C++, which is what we're going to be messing with, but we've got a bunch of stuff. So over here, we've got the editor panel. Over here on the right, we're going to see the assembly that comes out. So like, for example, if I declare an int, here's kind of the Intel assembly. So here, this is Intel using GCC 15. And then over here, we
What
have,
is what is what does
Mhm.
dot zero mean? Sorry, I'm gonna just interrupt you a bunch if that's okay.
Yeah, of course.
I have so
Yes.
many questions.
Yeah.
I
So,
can give you a little bit more of my background on like my level of knowledge when it comes to C.
yeah, well,
And
yeah. Yeah, we'll do that after we kind of go through the, I guess, this UI, since we'll be messing with this here. So basically, this is saying we're zeroing out 4 bytes.
what does zeroing out mean? By the way, everyone, I have 7 years of professional experience. So if you think you can't do it, you can, because I don't know what zeroing out means.
Yeah, so in a binary, right? So like a .exe or like a Linux executable, there are different sections, and one of them is basically a special section where you have certain objects of certain sizes, and all it basically does is it guarantees that the object is filled with zeros. So
Okay,
all the
but
bits are set to zero. So this is 32
okay,
bits. They're all zero.
okay, but you said it's four registries. So is each it said it's zeroed out 4 bits or
Four bytes.
4 bytes, and that's 32 bits because there's eight
There you
bits in a
go.
byte.
There you go. Exactly. Yeah. So right, so we put in our stuff here. We get our binary or our assembly language here. Up here, this is where we have our options. So we can mess around with C or C++, depending on what you want to do. I currently have like the newest fancy version of C, C23. And
That's what I want to learn because I don't
yeah,
want to learn any old stuff.
get rid of that old stuff. Get it out of
Well,
here.
I mean, what I mean is just like if there's new features in C23, I might as well learn them if it makes using C more pleasant.
Yeah, that makes sense. So to that end, I've also turned on some of the fancier GCC features. So there are all these like a million flip guns, right, with C. And so over time, the compiler engineers have been thinking like, how about we provide some armored shoes so that when you blow off your foot, it ricochets off your armored shoe and your toes are intact or something. So
Is that the analyzer?
we got the analyzer, and then we're turning up all the warnings basically.
That's actually was one of my questions because so I started reading this operating system book called Three Easy Pieces or Three Pieces or something like that, and it talks about dash wall. So I thought dash wall was like, oh, it puts a wall up or something like that. I was like, but now that I see that it's dash W all, dash W extra, dash W error, and you said it was a warning, these they were warnings. So
Yeah,
it's
yeah, yeah.
all warnings, extra warnings, error warnings, and pedantic warnings.
Yeah, you got it. Yeah, exactly. So yeah, we're turning everything on, and some of this seems a little funny to me because I think basically like I don't think all means all, right? Otherwise you would need all these other ones. I think all is like, yeah, let's do all of them, but it's like, wait. That's a little too many warnings. And so then it's like, oh, you want to be pedantic about it. And this one here says treat all warnings as errors. So what's going to happen is
Oh,
like
that's cool.
there's a lot of stuff where it's like, yeah, technically it's allowed. It's like an old style of programming, and it's not. You shouldn't do it anymore. But you can. It's allowed for backwards compatibility reasons. With this turned on, it's gonna like not allow you to build. So
Okay, that's probably for the better.
yeah, I think so. So that's basically Compiler Explorer. What we're gonna be doing is taking turns, kind of writing code in here, talking about the output. And this isn't like a live share thing. They're not quite to that level yet. But what we can do is we can hit share and we'll generate like a link and that will be backed by kind of like all this the state of this window serialized. So we'll just kind of beach ball that back and forth. That sounds good to you?
Yeah, that sounds great. Sorry, I'm just turning off my my phone real quick so that it doesn't go off again during the call.
Yeah, no worries. Um, cool. So yeah, why don't you talk about your programming background since you mentioned that earlier, and then we can kind of use that to dial in on maybe some of this kind of these C language concepts that you want to talk about.
Sure. Can I talk about how we know each other without going into too many specifics?
Yeah, sure.
So I actually went to a boot camp um, that Sean went to, and I was in a cohort after one or two cohorts after him. And one of our mutual friends from his cohort basically posted something that the company that Sean and her were working at was looking for people, and so Sean and I worked with each other for 3 years, and it was like right after I learned JavaScript and some CSS and some HTML, and I knew nothing else.
And look how far we've come.
Uh, yep, and then I hashtag grinded lead code and got a job at Meta, not Meta, got a job at Amazon. I'm jumping the gun. And my last day at Amazon is this Friday, and I start a new job at Meta next week. At Amazon, they use like a TypeScript, Python, and Java stack. Python for big data or AI, ML related work, Java for backend web services, and then TypeScript for front end and infrastructure. And the job I'm going into at Meta is going to primarily be C, C++, and that's why John agreed to teach me something because he knows a thing or two about these languages. So thanks, John.
Yeah, of course. Yeah, so I think it's probably okay. So you're talking about Kate earlier, I'm assuming.
Yeah.
Yeah, so folks that have been following me on YouTube for a while might have seen some of the videos Kate and I did on Rust way back when.
Oh, that's
What
cool.
about however many years ago that was, many years ago. Um, cool. So um, I've basically pulled up a website that is a very good bookmark that I would suggest. It's called cppreference.com. And despite the name, it's got both C and C++. So if you go to the main thing, you've got C++ here at the top. You scroll down, here's C. So I clicked here, and that took us to this page. Um, so the cool thing about this site is it basically takes the high level information from the language specifications and takes it from like compiler-ease and turns it into something that's more usable for as the primary reference for people that actually write C and C++. So some of these articles are actually very good for learning concepts and things, and they've got some code examples and things in here. Um, and yeah, so I like this page here because it kind of has a good like map of everything that's in the core C language. Um, and I was thinking a little bit about like, compared to like Java, what would be things that I would expect to be more unfamiliar. And I guess I can throw out some ideas if that'd be of interest to you.
So I'm really bad at Java. Um, but yeah. So if that's what you want to do, you can do it. But if you just explain C, that's probably fine too.
Okay.
I'm also familiar with Go because we learned Go at the job we showed.
Yeah.
And so I did Go for like 2.5 years.
Okay. Okay. All right. So let's
Actually, you
start.
know what? Can you explain things in terms of JavaScript? Because that
Yeah.
actually would be, or Python, because I would say those are my two strongest languages.
Yeah. 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 Okay. So cool. So compared to JavaScript and Python, I think probably a good first place to start is types. So
Okay.
in JavaScript and Python, when you declare variables and you declare objects, they are loosely typed. So you can assign an object, you can assign a string, you can assign a number. Those can change around. And then it's like more recently, everyone is like, oh, we like types now. So you can use TypeScript or you can use like whatever that typing pep thing is in Python to like harden your things. So we only allow numbers
Yeah,
here. We only allow strings or whatever.
they're basically compiler decorators.
Cool. Yeah. So C is old school, where basically when you declare an object that you are saying like, here's the type. At compile time, I guarantee this is the type of the thing, right? So at that point, it's kind of locked down.
Can I ask a
So
question?
yeah,
So
of
we
course.
looked at this letter A and it zeroed out 4 bytes.
Yep.
Is part of that 4 bytes zeroed out something that tells us that it's an integer? Or
Um,
is there any memory put aside for storing the type?
yeah. So there isn't. So basically, like what you're talking about is kind of what type information is stored at runtime. So
Yeah.
a lot of the type information is only known by the compiler, and then when assembly gets generated out, the type information isn't necessarily there. And that's actually a big difference from like an interpreted or like virtual machine kind of language because they do store all those types there. And so that's actually one of those foot guns here because like C tries to make things like as close to the metal as possible, and you can lose some of that type information, and that can open up some vulnerabilities potentially.
Yeah, cool. So if people
Um,
know what the memory address is, they could modify the values.
yeah, so when you declare an object, you can use what's called casting to basically say, hey, this was an int, like now it's a pointer, or now it's this, or now it's that. And you can actually do things that are nonsensical that will break your program pretty easily.
Okay, so like in Go, if you make something an int, it's always an int. But in C, if you make it an int, you could change it to a float later. Is that what you're saying? Or a pointer?
Yeah, you can cast it to a different type, and there's like a bunch of complicated rules about what that does under the hood.
Oh,
So,
okay.
but like generally, like that, a good way to kind of think about it is casting is kind of a code smell. It's like something you should try to avoid. If you see a lot of casts, um, be wary about what's going on there because it's kind of
Okay.
like you're making all these promises with the type system, and when you cast, you are breaking those promises. So sometimes you got to do it, but yeah, just be mindful of it. But I guess let's talk about the different types we have. So if you kind of want to think about different categories, the scalar types are kind of like our basic built-in types,
Are those
and
like primitives?
primitives, yeah. So
Sure. I've never seen that before. Is there a tall? There's a long.
There's a long, long, yeah,
Oh my god.
yeah. And
I
so,
I've already loved this language.
oh yeah, it's good times. All right, so here we've declared 5 objects, and then like we kind of talked about what this meant. So I renamed this to C, but this 32 bits or 4 bytes, and you can kind of see what the size of the other types are here.
So is the short the opposite of a long? So it's like it's an integer, but it's less bits.
Yeah, it's narrower. And
Okay.
so one thing here, I'll start listing off some fun quick guns here. All right, so
Okay.
C came out in like the olden days when
Was it 72, 73?
yeah,
I don't know.
72. I mean, it kind of depends on when you want to start counting it because it evolved from previous languages before that too, like B. But yeah, I think 72 is probably what Wikipedia says. Um, and then the language got standardized finally in 89. So it took a while. But back in like the 70s, all these computers looked a lot different. They're like IBM machines, Univac machines, like Burroughs machines, all these different weird mainframes and mini computers and stuff. And all these different types of computers had different size numbers. And
Oh,
so,
because it wasn't standardized yet.
yeah, it wasn't standardized yet, and everything is a lot more converged and looks similar to kind of 64-bit Intel. Everything's relatively close there. Oh, things were a lot crazier back then. So, what has happened is these basically like there's a guarantee that a char is well, actually I don't even think I can say that. For the most part, you can kind of think that this is narrower than this, is narrower than this, is narrower than this, is narrower than this. But if you look here, you can see two things are equal. So they may not be, it's like less than or equal to. And then things can even get a little bit more complicated with char, I think. But yeah, so these imply like different sizes. They don't necessarily imply a specific size. And
Because it depends on the compiler
it,
and the system it's
it
on.
depends on both. Yeah. So it depends on the compiler and then it depends on what architecture you're targeting. So like
Okay.
if I go to 32-bit Intel or something,
We don't talk
oops,
about that anymore.
yeah, yeah, that's not even that's some ancient version. All right, let me do some other architecture. Power architecture, sure.
It's
All
oh,
right,
okay. Longs
so
are 4.
yeah, so this is Power PC things on from IBM. So that's different here. So that's kind of a challenge. Like if you write portable code, the backing number of bits for these integers can be different. And so that means like if you wrote code here that assumed a long can store 64 bits of information and then you try to port to PowerPC, bad things happen.
Well, so one of the things that I learned from Go, and I think I saw also when I was like reading some stuff about C recently, was that isn't there like an int underscore 32 type or an int 64 type
Mhm.
so that you can get around this?
Yeah, yeah, yeah. We do have that. So we can include,
And can I ask a clarifying question? Just since I'm really new, .h means it's a header file.
yes, yeah. So
Okay.
a that is a header file. What do you know about header files?
Uh, I just know that they're not. I just saw that there was .h and .c,
Yes, right. So
and that's,
basically,
that's all
yeah, yeah,
I
yeah,
know.
yeah, yeah, yeah. That's a good start. So a header file, um, basically what happens is you write C code into it, and
Okay.
you can kind of think of it as the public interface of some module of C code. And what happens with this include is all of the characters in std.int.h basically get expanded out like a big macro.
Okay.
And so I think let's go to Grok. Um, how
Do you
can
paper Grok? I'm just curious.
I do?
I
Just
paper Claude. Do you think Grok is better than Claude?
um, It's hard for me to tell the difference, honestly.
Okay.
They're both pretty good. I like Grok is very good at like you throw in code and it can explain it really well. Um, and then I think for like generating code, they feel pretty similar to me. Claude, like I think Claude probably has a little bit of an edge there.
Okay.
All right,
I
so
used Meta's Llama 4 for the first time last night, and it just felt way more conversational. That was like the only thing I really felt different. I guess they call it like a vibe, the vibe test.
the vibe test.
Yeah, Claude has no vibe.
There's no.
Claude is it's purely informational.
So well, I guess it's kind. I mean, like Zuckerberg wants you to date your chatbots, right? Is that the
Um,
idea? Didn't he go on a bunch of
so
podcasts saying how
I'm gonna start
Oh, right,
my
yeah, yeah,
job at
yeah,
Meta on
that's
Monday,
right.
so please don't say anything
That's smart.
um,
That's smart. Yeah, yeah,
like
yeah.
that. Is I do not endorse those kinds of opinions
Okay.
in public.
All right. So we are going to go back to not PowerPC, but to Intel again, and then we're going to expand out a header.
Oh, we're gonna use 23, right?
It's still in there.
Okay.
So I believe what I learned from Grok is if I do this E, you can basically see what the include turns into. And so that's all of these lines here.
Super interesting.
So here you can basically see what all these standard types are. So with C, you don't have namespaces. And so the problem is if you write like any sort of public symbols, like there's a chance that you might collide with someone else because it's all one big namespace. So when you bring in standard library code, you will see these kind of like double underscore types of things. And I believe it's double underscore is reserved for the compiler, single underscore and a capital is reserved for the compiler. So if you define any symbols with like an underscore or two underscores in front of your stuff, it's considered basically undefined behavior. You might break stuff. But yeah, so if we go down here, eventually, here we go, int 8. So here's this. So this is saying we are defining a type, which is not really a type, it's type alias. The name of the alias is int 8. Int 8 is behind the scenes and a double underscore int 8. And then up here, here's the other thing. So we can see it's a sign char behind the scenes.
Okay.
So all of these standard types they're just like indirection, and they end up being whatever the correct incantation is of chars, shorts, ints, longs, long longs to get what you want.
Interesting.
Um, cool. Uh, any questions that come to mind off this?
Nope. What you said we started with scalars. What was the other type?
Yeah, so other than scalars, we have more complex types.
I know struct. I've heard of a struct.
We got a struct.
Is a boolean considered complex?
So a Boolean is actually kind of a newer thing in C. So
Really?
C
Okay.
originally had no Boolean, right? So what C originally had
0 and 1.
was an int, and a zero is false. Anything other than zero is true. So
Oh,
like in
that's similar
JavaScript,
to. Okay.
truthy, like it's kind of like truthy in JavaScript.
Yeah. And then also
Um,
Go. Whenever you initialize something, it's always 0 if it's an int. Does that make sense? It's like the empty state versus the non-empty state.
yeah, and then later on, I think it was maybe C95 or something. They're like, okay, all right, well maybe we'll add a Boolean type, but they're like, we can't call it bool because what if people had variables that are named bool? We're gonna break all their code. We can't do that. And so I think it's the first iteration, which this is the old stuff you don't want to learn, but I'm a
I mean, it's
history nerd.
history. I like history.
So I think it's that underscore bool.
That is beautiful. That's how you write. That's how you write pretty code right there.
Yeah, and let me get rid of that E so we don't see all that stuff there. All right, so we got ugly baby, and then with C23 they're like actually this is silly. We'll go ahead and break the code. So I think now we do have bool. There we go.
There you go. There you go.
Yeah, so I would say bool is a scalar. Um, yeah. So you said you're familiar with structs. So a struct basically is like a multiple things together. So um,
And do you have to give a pointer to a struct, or can you have like a non-pointer struct?
so yeah, that's kind of a difference. So in C, this struct can live on a stack like a primitive. So it can be faster. So let me just jump ahead. All right, so now we got a main function. So we can declare uninitialized, and it's going to warn unused.
What is the double brackets?
So this is called an attribute. And so there, in this case, I added it because the warning was saying the variable's unused, right? Which is probably a source of a bug. And we turned on pedantic and all that stuff. And so the attribute is basically telling the compiler, I know what I'm doing here. Let me cook.
Okay,
Yeah.
that's funny. It's
um,
almost like it's like mute in Rust, right? No, I mean that analogy probably doesn't work.
yeah, I can't remember. It's been too long for Rust for me. But yeah, it's a lot of languages have things like this. So um, yeah, and there's a whole list of attributes.
They should just LMC. They should like shorthand it to LMC.
The LMC.
Yeah.
Right. So here are kind of the standard ones. You can say it's a deprecated function. You could say the function doesn't actually return, like it's got an infinite loop or something. Yeah, that's the one we're using. All right. So um, the reason that I created main was basically to declare the struct here, because you're asking about like, is it accessed through pointer? So the way that this is declared is that this struct is totally on the stack. And so there's no actual pointer in direction. The data is accessed directly. If you wanted to add up to a pointer,
Can I ask a dumb question while you're typing?
yeah, yeah,
What's the difference between the stack and the heap?
yeah. All right. So inside of a inside of a binary, there's different sections of memory, which we kind of talked a little bit about with this zero thing. One of the sections is basically where the stack exists, and we change this to a simpler example. All right. So here in main, we are declaring an int a. Oh, come on. And when the program enters the main function here, basically the int a is pushed to the stack. So the stack grows, a is added to the stack. If I have a second object here, b is added to the stack. If I add a third object, c, what do you think is going to happen?
Gonna be added to the stack unless
Added
the
to
stack
what?
runs out of space.
The stack can eventually run out of space. It's got usually a couple megabytes. Depends if you're in kernel mode or whatever. But yeah, if you've got a good amount of space.
Is the stack in like the CPU cache?
So it's not in the cache, but it tends to be better for the cache because what happens is like we said, um, these are ints. So this is 32 bits. This is 32 bits. This is 32 bits. So like the stack squishes all these objects right next to each other. So we've got 96 consecutive bits here probably. And
Okay.
because the data is all squished together, it fits in the cache lines. And because the stack is used all the time, it's basically always a cache hit.
Okay.
So it ends
Hey,
up being, mhm,
sorry, just give me 1 second. I'm gonna mute myself real quick.
yep,
Sorry about that.
yeah, no worries. Um, so things on the stack end up being a cache hit, and so the performance advantages are pretty big. It's kind of like the speed of the cache versus accessing in main memory, which is like maybe 2 orders of magnitude, I think, off the top of my head. Um, and so that's like a cool advantage of these systems programming languages, because you can pack your data to be like very efficient for the cache, and for things that are like like high performance games and stuff, that ends up being why this lower level code's a lot faster. Um, so for something closer to like JavaScript or Python, what you're going to end up having is something more like this.
I learned what malloc means recently.
Oh, tell me, what do you learn?
I learned it means memory allocation. That's it. That's what
That's what you
and
learned?
it like sets aside a just space, like a certain amount of space, and then you have to clear it manually.
Yeah, yeah, exactly. So, all right, so this is not an integer, this is a pointer to an integer, which we
Okay.
might want to talk about. And that pointer to an integer is basically it's an object on the stack, and it contains an address in memory, and that's the address of something somewhere in the heap.
Okay. So the heap is access closer to the actual RAM. Is that a heap in the RAM or access?
So they're both in RAM, stack and heap. The stack is
Okay.
small, all the data is packed together, so it's better for cache. Um, and the heap is potentially longer lived. So it's like this. For the stack, we've got A, B, C. The start of the lifetime of A is this line. The end of the lifetime of A is 36 here, right? So for things on a heap, the lifetime is kind of like up until we free it. So like, if you could imagine, if this wasn't like main.c, if this was like some sort of utility function, you might call this thing a couple of times. Each time you call it, you have like an A that starts its lifetime and then ends at the end of the curly brace here. But the pointer might be longer lived. So I feel like that might have been a little information overloady, but yeah.
No, no, I
So
got it. I
you
got
got it.
it.
Okay. So
Yeah.
the main thing is that you have to be a lot more careful about lifetime issues with things
Okay.
that are on pointers to things on the heap, basically. Like you get more automatic cleanup for things on the stack, and the heap is a little bit more dangerous. So like, if, for
Also, it's
example,
easier for people to like look up or like hack things on the heap, from what I understand. Is that correct? Like I
yeah,
was watching like a low level learning video, and I guess it's like you can there's like commands to see what is on the heap,
yeah,
and so people can actually.
you can tell based off the addresses. They're in different parts of the address space. So the stack is all that. They'll have like different ranges of addresses, and the heap, it can be all over the place. Like it's probably randomized to some degree. Um, yeah. All
Cool.
right. Cool. So
I learned something.
all right. So structs. We talked a little bit about pointers. I mean, there's a lot to talk about pointers. um, so
So okay, let's get through the complex types, and then let's take like a 5 minute break, and
yeah,
then we
yeah,
can
yeah, yeah,
decide what we want to do next.
yeah. All right. Let's blast these guys out. All right. So we have structs. We also have unions. And
Not at Amazon.
shut that shit down quick. uh, yeah. All right. So basically, all right, with the struct, like if you kind of think about like the bits here, so we have like, you can kind of think about this as like all the bits. Here's the start. Here's the end. And so with the struct, like the first half is the A, and the second half is the B.
Okay.
Does that kind of spatially make sense? Although they're different sizes, so I guess I should do like 1/3, 2/3.
Whatever. Whatever.
Yeah.
I got you. I got you.
All right. So the main thing is like, this is a different set of bits than this. All right. So with the same thing with the union, it's a little bit different. What you end up having is basically you can have either an A or a B, and they use the same bits. So this is kind of like saying, like here we go. Struct is saying my struct is both an A and a B. The union is saying it's either an A or a B, like not both,
Oh,
right?
okay.
And so like kind of back to loose types. Um,
Oh, it's the same thing in TypeScript. So like but you just use a pipe
use a
to,
pipe.
to create a union type. So you're saying like
Yeah,
if
yeah,
you
yeah,
say
yeah.
something is
That's
a
right.
union, you can
Yeah.
either store a character or a short in that value.
Yes, right. So that, yeah, that's
Okay.
true. Um, the
But can you can't you could you because it's only so basically the union is one it's one but you store so you have the space for both.
You have the space for the largest possible option.
Okay. Okay.
Yeah.
So like I guess the better way to do this was that would be okay. So a short is 2 bytes. Char is 4. So if my union is you store short in my union, then 2 of the bytes would be full. 2 of the bytes would be empty, but still allocated to my union. And then if you wanted to, you could later store a car in that space
Yeah, and it would
if you use a
overwrite.
pointer.
It would overwrite what was there before.
But only with a pointer. If you didn't use a pointer, then it would create something new on the stack on the stack.
No, it would use the existing bits on the stack, so it would just overwrite what was already there.
Okay.
The
Okay. Never mind.
um,
Can I ask a dumb question?
yeah,
Is the reason why I use pointers is because if you don't, it's locally scoped to the function, and then anytime it gets passed to a different function, it creates a copy.
yeah, that's definitely one of the big reasons. That's the lifeboat
Okay.
thing.
Okay.
The other is kind of that size thing we were talking about. The stack only has a couple of megabytes, and
Okay.
when you overrun the stack, you crash the program.
Is
So
that only in newer versions of C? Because I thought like there's like especially in like older video games, there's a lot of bugs because of like that are caused by like some kind of memory overflow.
um, yeah, it would. I guess the behavior depends on the compiler version. Frequently now there's what's called a guard page after the stack, and basically if you touch any of the addresses in that guard page, the program dies.
Interesting. Okay.
Yeah, but yeah, older software may not have that, so it might behave a little bit differently. Um, yeah. All right, you want to pause now or take a break or?
What about? I feel like we're missing types. Are we not missing any types? What about like arrays or slices? I don't know what they're called in C.
Yeah, yeah, yeah. All right, so let me do this first. All right, so
Oh,
with
cool.
with C,
Nice.
you can declare 3 things of the same type like this. This gets a little confusing though. So, for example, do that. What do you think that these types are?
So I would say for the star, I know that's creating a pointer, but I'm not sure if putting a star makes them all a pointer or just a pointer.
Yeah, yeah. So typically, this is something a lot of people get wrong, but maybe because I set it up as a question, you're being skeptical. Yeah. So this ends up being a pointer to an int. This is an int. This is an int.
Okay, that's what I assumed, but I wasn't 100% sure because that would be like how I think it would work in like Go. I don't know if you can do that in Go though, but I know you can do multiple values in a line.
All right. So these are now all pointers.
Pointers. Okay, cool.
All right. So
But you can create a pointer without malloc.
you can, yeah, you can set a pointer to any address.
Okay, so it's just so basically all malloc does is it just puts it in the heap.
So what malloc does is it allocates an object on the heap and returns an address, which you can store in a pointer.
Oh, and then that address would still be on the stack.
You store the address on a stack. Yeah.
Okay, cool. Thank you.
Yeah.
This is the hardest part, right?
Yeah, yeah, yeah. It is. It is. All right, so then, all right, so we got 3 pointers. All right, so we can initialize these pointers. In C23, we've got null pointer.
Hell yeah.
Before C23, we had null. And I'm just going to mix it
What?
up. Before that, we had
0.
0. So depending on the code base, you'll see like all these.
They all mean the
And
same thing.
roughly, it's like this. If you use this, you end up having more type checks and things, so the compiler
Oh,
has
good.
warnings. If possible, this is something that came from C++ into C. So if you're in C++
Okay, cool.
or they definitely use null pointer like this. All right, so I believe let me. It's been a little bit since I've read the spec. I believe that this is I think a declaration statement. This whole thing, right? And the declaration statement includes 3 declarators, and I believe the declarators are this, this, and this. So they're like these are the comma separated parts. So this is the base type that all 3 declarators get, and then they each have this separate bit. This part with the equal sign is called an initializer because it sets the initial value of the object at the start of its lifetime. Yeah, and so you were talking about other types. All right, so we can, for example, add D, and we could say 10. And D is an array of 10 ints.
Oh, that's so interesting because like normally like in more modern languages, the whether or not it's an array is declared as part of the type itself, but here it's part of the variable.
Yeah, it's part of the declarator. So,
Okay,
and
the declarator.
yeah, and then and
Interesting.
I can do even weirder stuff. Like for example, this is saying,
I think you're missing a comma, no?
oh yeah, thank you. There we go. This is saying that somewhere in the program there was a function called add ints, and it takes 2 ints and it returns an int. So the base type here ends up being the return type.
And it doesn't give any warnings, even if there's not an add int method or function.
Um, I don't think it will do that unless I try to call it. So, yeah, you're right. It doesn't actually exist. Here we go. Undefined
Oh,
variables.
because it says maybe unused prevents it from having an error.
Yeah, that could be the case. Yeah. Um, yeah. So right, pointers, arrays, functions. You can have pointers do functions that return something. You can have all sorts of crazy stuff. So then you can also add qualifiers. So there are multiple qualifiers. We've got const, vol, volatile,
I've heard of volatile and const.
register. All right, so const is the main one. So I can throw that on here.
Nope.
Need that if I get rid of that.
Nope.
Now, there we go. Now we're
Oh,
good.
oh, cool. Hell yeah.
All right, and so this is saying A is a pointer to an immutable integer. B
Oh,
is a pointer. Yeah,
I
go
thought
ahead.
it made it so that the pointer itself could not be mutated, and then you
Not
could still
quite,
mutate
not
the
quite.
value.
So
You can still
so
change what the value is.
so this is this is a mutable pointer to an immutable integer. The way this is written.
Oh, interesting. So you could basically change what the pointer is, but the integer that it's going to can't change.
Yeah, right. But back to our difference between the base type and the declarator. You can have an immutable pointer, and the way that you do that is like that.
Oh, that feels bad.
So it has to basically be after the asterisk for the pointer, and you can have qualifiers here, and then anything to the left hand side would be the base type.
We have a const int pointer, const null pointer.
Let's clean that up. All right,
that
let's.
that's maybe unused.
Yeah, all right, so it ends up looking like this by itself.
If I ever see a code base that has this line of code, I'm going to turn and run.
I mean, you will definitely see stuff. You'll see stuff like this. And right, it wouldn't make sense to set a null pointer that's an immutable pointer because it's like, what do you even do with that? It's useless. But yeah, right. So you could have an immutable point. You could have an immutable pointer to a mutable value, right? You can have a mutable pointer to an immutable value. You can have a immutable pointer to an immutable value. Yeah, so that's const, and that's the qualifier you'll see the most. Volatile, I don't think it's worth talking
Volatile is
about too
useful.
much.
It seems like it's well. I saw volatile in a lot of the examples for the operating systems book I started studying.
Yeah, right. So for code that interacts with hardware, that's kind of where volatile comes into play. Because like the compiler kind of makes an assumption that all these objects that are out there in the memory space, like it has perfect knowledge of everything. So it's like, I'm the compiler. I created this A. I set it to null pointer, and that means the next time that I touch this A, I assume it's going to be the last thing I set it to. That's usually true, but for like certain lower level code, the hardware itself might change the value, or there might be some other entity. And so if there's something the compiler doesn't know about, it's basically like when you put in a volatile, it's basically saying make no assumptions about what's in there.
Okay, yeah, I think the context I might have seen it in, and I might be wrong, was with like multi-threading.
Yeah, yeah. So and some of that might be out of date information. So like volatile used to be recommended more for multi-threading, but there are better things, better like atomics and things that are suggested instead of that now.
Oh,
So
very cool.
yeah, right. And then register is kind of a more advanced things for pointers. It's a little overkill to talk about that right now, but yeah, these are the qualifiers. They can be on the base type or they can be on the qualified declarator piece. Yeah.
Cool. Okay, well, I think maybe this is a good point to take a break. If you want to take a break,
Okay.
we've been
Yeah.
going for an hour, I think, and then if you want to go for another hour after we take a 5 or 10 minute break, I'm down.
Yeah. Sounds good.
Cool.
All right, and we are back. So during our break, we started having some audio issues, uh, and I think probably the listeners can hear some of these issues. What's going on with your audio, Joe?
I have a System 76 and the fan is blowing really loud. And so that's getting picked up. And yeah.
Okay, that's fun. Well, System 76, you really should try to improve some of your thermals, I suppose.
Yeah.
Yeah, but yeah, I have. Well, I've really enjoyed having a chance to talk about some of my favorite things, which is C declarators, C statements. We talked about scalar types. We talked about complex types. This is some good stuff.
Yeah, I feel like I learned a lot. I feel like the most common, like the most similar language I've coded into this is probably Go.
Hmm.
And it's cool to kind of see where a lot of that came from.
Yeah, yeah, yeah. So yeah, Go specifically, like it it's kind of interesting. So it's created as like the anti C++, right? C++ is the big monster Hydra language with all the features. And Rob Pike and Ken Thompson created Go to be kind of the simpler, easier language that is like the spirit of C, because C is supposed to be like easy to use, right? Like the C programming language book is like very thin, like you can read it in a couple of hours. And so Go was trying to have the same sort of thing, but have like actually have an idea of what a computer network is. You can like make web requests and stuff. What a novel
Yeah.
idea. Um, so yeah, so there's definitely some interesting connective tissue here. Well, but I hope that some of the C foot guns and complexities haven't turned you off to wanting to push forward on this.
No, it actually, it's very exciting, because I have never really done anything like this. And, I think this is a good opportunity to learn.
Awesome, awesome. Well, I know you've got a move going on. When do you think you're going to be kind of settled?
In like 2 months.
Okay.
But we can still chat in like a week or two.
Okay, nice. So in like maybe a week or two, we can try to pick up on operators and expressions. I think that'd probably be a good next place to hit. Does that sound good to you?
Yeah, and that sounds good to me. And hopefully, I'll know some more C by then. And I can show you my finger pistols.
Yeah, well, and at some point we can also swap around and maybe you can give me some leak code instructions.
Yeah, let's do that. Let's grab we go. Okay.
You got anything you want to say to the audience before we sign off?
You can learn anything you want to learn.
That's great. I'm inspired. Yeah, so both of us went through Full Stack Academy Coding Bootcamp. We are a number of years out. We're hanging in the industry. I'm turning 40 later this year. In the past, I was told 35 is when you age out, but I'm still hanging in there. And I that said, I am totally unemployed. So I don't know. Maybe we'll see. We'll see if I'm able to get a job again. But hey, I'm optimistic, even with all this AI stuff, right? It's. Would you recommend someone pick up coding today?
Yeah, I think that now more than ever, it's something useful to learn.
Awesome, awesome. Well, cool. Well, if you've enjoyed watching the two of us cover some C programming language stuff, I think we'll put up some additional videos in the future. And in the meantime, hope you all have wonderful May 2025.
Thanks, Sean.